yesterday we talked about zeros and vertical asymptotes, remember? Yes, no, maybe so?
Yeah.
Okay. Today we're going to talk about two different topics that are similar. We're going to talk about horizontal asymptotes. So those are when there's a line side to side that the graph can't touch or cross. And then we're going to also talk about things that are called points of discontinuity, or basically a hole in your graph. So you're walking along your graph and all of a sudden there's a hole. Kind of like if you walk along and somebody's doing construction on the sidewalk and you're like, oh, that piece of sidewalk is gone.
Or you're just on a road in Michigan.
Yes, or just on a road, pothole. Yes, another perfect example. So we're going to talk about horizontal asymptotes first and holes second. Yeah. Can you have what? Yeah, you know they're there. They're in the back. I put more in there yesterday. Okay, and then we have some classwork on it as well. So yes. No, are you in the bonus notes? Did I staple two? Okay.
It's like, wait, yeah, he has another day too.
Well, you got an extra day too, just for you. Okay. Well, I stapled them myself, so they were homemade with care, but apparently not very much care. Okay. Here we go. So there are three rules for horizontal asymptotes. If the degree of the numerator is larger than the degree of the denominator, there is no horizontal asymptote. So let me show you an example of that. So if the degree of the numerator is larger. Okay, so look at this example. Remember, your degree is your biggest exponent. So if I look at the degree of my numerator, do we agree the degree is 3? That's the biggest exponent in the numerator? Mm-hmm. What's your degree in your denominator? 2. So if the degree in the numerator is bigger, then you have no horizontal asymptote. So sometimes our answer can be, what's your horizontal asymptote? There isn't one. Okay? Next, if the degree of the numerator is smaller, okay, we all saw that? Okay. I'm not seeing things. There's somebody dressed as a bear outside. It's fine. It's probably fine. Okay.
Sure?
I'm not, but I'm hopeful.
This board recorder is going to have some strange.
Yes, no, this is going to be an amazing video. All right, do you see how I flipped the fraction? And now, do you see how the degree of the numerator is smaller than the denominator? So when that happens, our horizontal asymptote is at 0. So this one was no HA, no horizontal asymptote. This one is 0. So you have to look. It's going to be one of these three situations. There are no other things it could be. So if the top is bigger, none. If the bottom is bigger, 0. It's at 0. And again, you have to write y equals 0. These are y equals, like yesterday, where x equals for the vertical asymptote. If the degree of the numerator and the denominator are, what's the only thing we haven't talked about? What's the third option? One can be bigger than the other, or what else could they be? The same. If the degree of the numerator and denominator are the same, then the asymptote is the ratio of the leading coefficients, which sounds like a crazy statement, so I'm going to explain to you what that means. Okay, do you agree that this is an example where my exponents are the same? Yes. Question? Yes. Okay, so for this one, again, it has to be in the form y equals. When it says ratio, ratio is another word for fraction, and leading coefficients are the big numbers out front. So your horizontal asymptote is going to be at 3/7. So you just take your leading coefficients. So this is where my horizontal asymptote would be for this example. And again, this was y equals 0, and this was no horizontal asymptote. Okay, so those are the three things that can happen. There's no like mysterious fourth option. These are the only three things that can happen. So let's look at some examples and start there. So you have to first kind of diagnose what you got. So look down here. Remember, if there's no exponent, it's degree 1. So look at problem 1. Is the degree of the numerator bigger? No. Is the degree of the numerator smaller? Yes. So it's number 2, and my asymptote is y equals 0. So you have to figure out which one it is. Figure out which one it is, and then go from there. Look at the next one. We have 3 over 1. So I'm just going to start at number 1. Like I kind of think of it like I go down the list every time. Is the numerator bigger? Yeah. So we have 3 and we have 1. The numerator is bigger. So what does that mean? If the numerator is bigger, just none. Yeah. So I'm going to write no HA, no horizontal asymptote. What about the last one? What are they're the same. So when they're the same, this is going to be y equals 4/5. Okay, pretend for a second before we flip the page. Pretend this 4 wasn't here. What if it had just said x squared? What would your leading coefficient be?
1.
Yes, good. So if there's no number sitting there and you're like, well, wait, what is it? It's missing. It's a 1. Okay? All right, you can flip when you're ready.
Wait.
I'm waiting.
How'd you get 4, 5?
4, 5, leading coefficient. Boom, boom.
Oh, gotcha.
And we just discussed too, Demise, that if, like, let's say the 4 hadn't been there, it was just an x squared, then it would be 1/5. Yeah. Okay.
You're not using the mug with the face on it?
I am not today. I felt like I used the mug yesterday and I was a good parent, and I feel like that's one day with that mug is all I had in me. Yes. Okay, so make sure you have this written down, flip the page when you're ready. We've got one more topic. Although I did discover that all the mugs look the same.
Okay.
So that makes me feel not the same, but like that design is what they were told to do.
Okay.
So my Ellie's best friend, I sent her mom a picture and I was like, are you frightened by these mugs too? And she's like, oh no, my daughter's is the same. This is her mug.
Okay.
Now granted, huh?
Whose mug is that?
This is my daughter's bestie's mug.
Oh.
So granted, I like the teal better.
Yeah.
I gotta be honest, I like the red. I like the red better.
Oh.
But the red looks like you're just.
Yeah, it was a little more concerning when you
It-
think about, when you put the whole mug together. I felt.
I like your daughter's mug.
Is there a
Good.
picture of them together, like a,
You need a side by side? Oh, no, but I have Ellie's. Hold on.
yeah, I wanna see them.
This is gonna be a great video today, you guys.
Yeah, it's gonna have so much stuff in it.
I think it's like the fact that the nose looks kind of
If
broken.
it wasn't for
like
if it wasn't for it being dropped, it would be
Yeah,
better.
it would be, yeah.
that might be true.
Yeah, there.
But I think she went with it and she was like, that is part of my art. Part of the journey.
This video or something.
This video is something. Okay, points of discontinuity or holes occur when you have the same thing,
I can get another half.
probably,
Yes?
not yet,
That's all I was asking.
have the same thing in the numerator and denominator. Oops. Numerator and denominator. So this is when you have the same thing, and I'll tell you what I mean by same thing in just a minute. Actually, I don't have, I'm going to cross out some of my examples. I'm going to do example 1, and then I'm going to give you a couple different ones that match up more to what I have in the classwork. So we're gonna do example 1 and then I'm gonna add another one or 2. Yeah, I think I'm gonna add 2 more. So this is really number 2 and number 3. We'll add a couple. All right, in the top, do you see how there's an x plus 8?
Okay.
Okay. In the bottom, do you see how there's a difference of perfect squares? Let's factor it. If you factor it, think back to yesterday, because we were doing some factoring yesterday, right? What would that factor into? Start with your signs. What signs go in?
Plus and minus.
A plus and minus. What goes in front?
X.
X. What goes second?
8.
8. All right, now, do you see something that is a match, that is the same in both the top and the bottom?
Yes, that's plus 8.
The x plus 8. So that means that we have a whole at, and it's where this would be 0. Kind of like yesterday. Remember we were making everything 0 yesterday? Same game. What would make x plus 8 0 if x was?
Negative.
So we have a whole at negative 8. Or you can call it a point of discontinuity. That sounds much classier, but longer to write. Do you want to pass? Are you good? Yeah? Okay. I know you need another donut. You can have one while we're working. Hold on.
Hold your horses.
To Dr. Thomas.
Wait, does he prefer doctor now?
So he convinced them when he got his photo ID that he was a doctor. And so they put Dr. Thomas on his lanyard, and so, yes.
He's had it for a while
You
though.
for sure?
He's
And-
had it for a long time.
And like everyone's like getting them updated and changed, and he's too scared to get
He's
a new
worried that
one.
he can't convince the next person that
To-
he's also a doctor.
a doctor. Yeah.
Yes. So Be Nice might work on making him like a, we should make him like a, you know, what are they called when you get a doctorate but you didn't really earn it? Do you know what I mean? When they're like, they give them out to like random people.
Oh yeah.
Do you know what I'm talking
I
about?
know exactly what you're
Why
talking
can't I
about.
think of the word? We
Yes.
need to, okay.
Thank you.
Bye, friend, thank you. Okay, let's do another one. Okay, next problem, same thing. Ready? 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 Add this problem. We're not going to do the other ones. Please do. All right, so some of them are going to be factored for you on the classwork and on the quiz, and some of them are not going to be factored for you. So number 3 is actually the easiest of all the things if you look at it. All right, so look at number 2. Let's factor number 2. I can't do anything to the top, agree?
Yes.
Like it's x plus 3 all day long, nothing we can do. Difference of squares in the bottom, what can that factor into? Honorary doctorate.
Honorary doctorate.
Okay. Plus and minus, sorry. This video is epic.
This video, you honestly need to.
I know, we should, it's gonna go viral. Okay, plus and minus, what goes in the first spot?
What? Oh. I don't know actually.
X, right? You take the square root of this
Oh,
thing.
yeah, and then 3, right?
And then 3.
Word.
Okay, what's your match?
The X plus 3.
So you have a whole at, what would make it 0? Negative
Wait,
3.
why do you write that?
Because that's what we're finding right now. We're finding different intricacies in our graphs. So the horizontal asymptotes are the lines that our graphs never touch or cross. This is a spot where if you were graphing, there'd be a, remember we talked about continuous versus discontinuous and picking up your pencil. This would be a spot where your graph would be discontinuous.
What was the other answer again?
The other one, so if I go up
Eight,
here,
negative 8.
yeah. Yep.
Why did I just do that?
So when you are graphing these, you don't need to write this down, but I just want to show you. When you are graphing these, literally this is how we graph them. So you're going along, and then you would truly like put in a little pothole where the hole is.
Word.
Yeah, that's
word.
Okay. Yeah, very Michigan thing. Okay, look at number 3. 3 is the easiest. What's your match?
X plus 6.
X plus 6. You don't even need to factor. Where's my hole in my graph? Negative 6. So again, we're just looking at different facets of the graph.